Next up, we have our first technology presentation from FLIR Systems that Carl made more than a few mentions to. FLIR designs, develops, and manufactures technologies that enhance awareness of methane emissions in the field. And it's my pleasure to introduce Craig O'Niell, the Director of Business Development at FLIR, to speak with us today. As a reminder, you can still keep on using the Q&A functions to relay any questions, and we'll have a short Q&A session after Craig's presentation. Okay, over to you, Craig.
Thank you, Andrew. I appreciate it. And thanks to everybody for the opportunity to talk to you today. Short amount of time here, so I want to just start off with a couple of slides on who FLIR is, for those of you that may not be as familiar with the organization. We are a public company, FLIR, on the FLIR on the NASDAQ, with a market cap of 4.6 billion and headquarters in Arlington. And one thing that we do have is we have two different focuses within our organization. We do have a focus on government opportunities, and then we have a focus on really our industrial opportunities, is where our optical gas imaging portfolio, as well as our solutions in the oil and gas market outside of simply optical gas imaging would focus. And we're more than just a camera company. Outside of what most people believe, we're a full solutions company. A little over 40% of our actual annual revenue is out of products that have nothing to do with thermal solutions. So we're pivoting our organization to be more of a full solutions company. And we'd like to provide these disruptive technologies to both the industrial and our government or our defense industries within our core mission. For those of you that may not be as familiar with optical gas imaging, optical gas imaging has been a foundation of the LDAR industry for about 15 years now. The convenience of optical gas imaging, we often talk about it, it's E squared. Extremely effective in finding the leaks fast and at safe distances, compared to other different technologies. It allows you to see the leak, and it gives you that visual evidence. We talk a lot about emerging technologies, and there are a lot of emerging technologies out there that are very good at detecting leaks. A lot of those have extreme challenges in identifying the leak source and the leak location, and which is where optical gas imaging has been a foundation of LDAR due to the capabilities of not only detecting those leaks, but also finding the leak source and location. Efficiency of optical gas imaging with independent studies and field studies that have been done, it's 9 to 10 times more efficient and faster than the other technologies like a TVA or sniffer. And even CODA talked about it earlier. It's a pretty high ROI, not just in just the actual loss of leaks, but also the ability for organizations. And it was really interesting to hear a conversation which we've heard over and over about how these organizations learn more about their equipment and about their systems by utilizing optical gas imaging in their LDAR programs. A little bit on the optical gas imaging history, for those of you, again, that may be a little new. The first commercial optical gas imaging camera came out in 2005, called the GasFind IR. It was a foundational camera for the EPA through the alternative work practice for methane-21. We took the industry feedback through the first few years of that product and came out with our foundational GF series, which is still the foundation product for us today, and advanced that product in 2017 with our GFX camera that is ATEX certified to be used in Class 1 Division 2 areas. In 2019, we began getting outside of the regulatory confinement, and we launched the first version of an uncooled camera. And I'll talk a little bit about this next, but what that is it's an optical gas imaging solution, specifically with this original product, specifically geared for methane detection. It is not quite as sensitive as our GF series and our cooled solutions, but it allows organizations to be able to go out there and in essence, this is that piece of the puzzle that is a next generation technology for methane mitigation that's not directly tied, as optical gas imaging has historically been, to regulatory check marks. Earlier this year, we did come out with the first FLIR branded quantification tablet. This allows you not only to use your cooled optical gas imaging cameras that would be used for quad away or alternative work practice operations, but allows you to actually take the details or take the information out of that camera, put it into this tablet, and directly quantify that leak that you're seeing. And then actually Monday of this week, we launched our second generation of our uncooled system, adding some lenses and broadening the scope of this outside of just methane, which may not apply to this market, but it shows our investment to the overall environmental issues, to be able to provide a wider scope of products to meet the needs of the globe. As we look at methane mitigation technologies that we have outside of our historical cooled cameras, as I mentioned in 2019, we came out with our GF77, now called the GF77LR. This is about a third as sensitive as our cooled solutions, and it is directed and it is focused specifically on methane. It's engineered as a lower cost solution at around 30, it's around 30 or 40% of the price of a cooled system, but it is about the same in sensitivity. It will have about 30% or so. It's about a third as sensitive as a solution as our cooled systems. This will not meet your quad OA standards and your quad OA requirements, but it allows for companies like the ones on this call that are interested in furthering and advancing their methane mitigation outside of regulation. For those that might be interested in the same solution, but with a fixed mount opportunity, we do have that as well. We have our GF77A. It is the guts of our GF77LR built into a fixed mount state-of-the-art automation camera. So now this can look out, and we can, we're working right now on the analytics, which is one of the video you see going in the background. So we're working on the analytics and getting a better analytics, but we have industry partners out there with deployable analytics. And then for those that might be interested more in that mitigation, but also meeting some of the regulatory requirements, whether it be federal or state level in some of the states that you may operate, we do have a fixed mount version, a continuous fixed mount version of our G300A or our quad away compliant camera in a G300A, allowing you to have a fixed mount continuous operation for methane mitigation that would be equivalent to what you're looking at. And lastly, just what do some people say in the industry about our solutions? I won't read all of this, but highlight what's coming up in red. One large industry partner said, utilizing this, not only does it have a high ROI, it great for environmental stewardship, but it also helps save lives. And that's a key foundation of FLIR, that words directly from our customers, that this is preventing an accident that could have possibly killed someone. And if you look more on the compliance side, outside of the ROI piece and next generation, reducing the NOVs that you're going to have, and allowing an organization outside of regulation to reduce its environmental impact and protect its reputation as a respected corporate citizen for emissions mitigation. So with that, I will pass it on to see if there are any questions that we would have, Andrew, that I might be able to address related to optical gas imaging or FLIR in general.
Yeah, thanks, Craig. Yeah, we've got a couple of questions that have come through. The first one is, can you elaborate on how the OGI cameras speciate between different types of gases, including
Yes.
water vapor?
Yeah, so, the cameras are not going to speciate. That's one of the, with optical gas imaging, we have two different foundational cameras for OGI. We have our cooled system, which is going to be geared around hydrocarbons, right? So if it is a hydrocarbon bond of a compound, all of those have a very similar absorption spectrum in the infrared wavelength in a what's defined as midwave. So it's just going to see a leak and going to tell you it is a leak. If you're using a GF320, it's going to see a leak and it's going to know, it's going to have the ability to say that it is a hydrocarbon leak. The new camera we have, the GF77LR, That camera is not going to be a broad hydrocarbon. It's made in a long wave infrared, and not to get too technical there, but in general, it is specifically designed around visualizing methane and other similar compounds. When I say similar, similar in infrared absorption. So it's going to be a little bit challenging with that one to be even, to be able to speciate. Now, how to tell a infrared image from a hydrocarbon gas from steam, a lot of that is just going to be user experience, which is why we do have certification training. We've just launched a free or a lower cost online training for optical gas imaging operators at irtraining.com. And so it's going to be more of a training piece and understanding the application of what you're looking at than it would be to be able to say that it's going to speciate and tell you this is a hydrocarbon leak versus this is a steam leak.
Craig, we've also had some questions about sort of like what the cost of such a system might be, or like what the maintenance requirements and total cost of ownership of such like a camera system might be. I wonder if you can speak directly to price tags, like what's a typical maintenance requirement, or what's it take from the operators to use one of these things?
Yeah, so the GF320 camera, our cooled operation, or the GFX320 cost of operation, you're going to be looking at around it's going to be around a $90,000 to $100,000 price point to get into to have that camera. That's going to be the camera that would be foundational for your LDAR organization that meets environmental compliance. In operational cost, reality is that you could send it in for an annual maintenance if that's of preference, but there are customers that we have that have cameras that have been used for 5, 6, and 7 years and have never once been sent in. There may be minimal cost of replacing batteries or doing this, but we would recommend every couple of years at a minimum, every couple of few years at a minimum, to send it in, get it looked at, make sure that it's operating efficiently, and that cost would be around $2,500 for each time that you'd send it in for that. And there may be minimal repairs when you do that. The new camera, the GF77LR camera, that is going to be methane centric but does not meet the regulatory requirements through EPA, Quad OA, or any really state levels. This is going to fit that initiative of next generational methane mitigation technologies. It's going to have a price tag just shade under $30,000 for the camera, and allows you to get out there and advance maybe some of your LDAR, and as Coda mentioned, they do a lot of optical gas imaging outside of regulatory constraints through LDAR and Quad OA. This could be a solution right there for them to be able to use an optical gas imaging to confirm any of that AVO issue you may run into.
Great. We're just about out of time, but I think there's probably a question with a quick answer, and that's what's the lowest range of methane that the 77 can see? What's the sort of detection limits with this type of technology?
Yeah, we have minimum detectable leak rates. A rule of thumb would be compared to our optical gas imaging cameras that are the trademark of the industry, our GF320, GFX320. Those are going to have a minimum detectable leak rate of around a little under 1 gram per hour, or I think it's around 0.6 to 0.8 grams per hour as far as a minimum detectable leak rate. In general, our uncooled system is going to be 3 to 5 times greater. So we'd be looking at around a 2.5 to 3 gram per hour minimum detectable leak rate, which is still very, very low. It's not designed to do two things. One, it's not designed to meet the minimum standards of Quad OA, but this is also a camera that's engineered to visualize methane and not as much engineered to visualize propane that doesn't have absorption in the spectrum that it falls, which means that a Quad OA 50% methane, 50% propane leak would not be as visual with our uncooled system as it would be with our cooled system. I know we're running short on time, but I'd welcome anybody that would like to reach out and answer any questions related to optical gas imaging. We're here to help you out. We're here to help you LDAR programs, and more importantly, we're here to help you in this next generation of methane mitigation to make sure that we are a part of the tools that you'd like to have to meet your metrics that you have.
Thank you so much, Craig. And we can gather the questions that we didn't get around to answering, and perhaps you can have a stab at them, and we can distribute them after the answers after this.
Thank you.
after this webinar.